later. So here's a question in 1.4. You know, what's funny is this is not a line. I feel like chapter 1 is all about lines. This is not a line. It's some other function. It's a parabola. We'll discuss that later. But they ask for this function shown here, find the average rate of change is what they ask for. And I guess average rate of change is slope. We've sort of said that. Rate of change is slope. Average rate of change is slope. But usually when something's curving, you don't think about a slope. I mean, when you have a line, you think about a slope. But I guess if they've given me 2 points, which they have, then the idea here is the average rate of change is the slope of the line that would connect the 2 points. So there's no picture of a line there, but if there was a line there, then what's that slope? Or what's the average rate of change between these 2 points on this function? So it's just worded funny and displayed funny, but it really is just another slope question, which is subtract your y's, that's a -1, minus 5, subtracting my y's, and subtract my x's. And I know you might not be able to see this too well, and that's a 1 minus a -2. So I think I get -6 over 3, and I think that's -2. And that's my slope of the line that connects those 2 points that are on some other function. It's kind of the average rate of change of this function between those 2 points, I guess. I'm just going to type that in and see if I got it right. I'm sure I did. I'm sure I did. Well, -2. Yes, nice work. Next question. Are you guys okay with that one? Okay, again, could confuse you, but when you read the words, that should make you think slope. Ultimately, you've got 2 points here, you find the slope. I mean, you could almost ignore the picture, but let me see, I think there might have been another one similar to that. If I go, see, here's another one. This is interesting. Look at the way this one's worded. This is without a picture. This is, and I'll blow this up, I'll write this a little bigger. They say you're on this function. Again, this function's not a line, it's not a linear function, but they want the average rate of change between these 2 x values. They say when x is -6 and when x is -5. They want the average rate of change between those 2 x values. Again, average rate of change is slope. If I'm going to do a slope, I usually should subtract my y's and subtract my x's. So what's funny about this one maybe is, look, they didn't give me any y's. They gave me these 2 x's. Can you find the y's? Yeah. How do you find y? You plug it into this equation. Thank you. So when x is -6, y is 36. You guys agree, I hope. And when x is -5, y is 25. And so now I've got my x and y values, and I can answer their question. Yeah, I can do this slope. So again, we did plenty of slope problems. I'm subtracting my y's. I guess I subtracted that way. 36 minus 25 over -6 minus -5. You got to be consistent. What is that? 11 over -1, which I could call -11, right? That's my average rate of change. Yeah, that's it. So we did plenty of slope problems, but I didn't really do any of these. But they're in the homework, and now that I help you with it a little bit, if you were confused, I think you'll be fine with this. Cool. So I'm kind of backing my way through this homework. Let me see, is there anything else here? Let's practice this one maybe. This is kind of a classic question. Again, if you have requests, you can interrupt me, but you were sort of silent, so I just took over. I got no problem taking over. But you can interrupt me and point me in a certain direction if you think we need to go in a different direction. So they want the equation of the line. They want the equation of the line. And by the way, let me read my directions. Type an equation using x and y as variables. Okay. Huh. They don't really tell me how to leave my answer. I would leave my answer in y equals mx plus b form. I hope that's what they want. But first I got to get there. What they said is it passes through a point. You know, when they say find the equation of a line, I'm thinking about this formula. And if I knew the slope, I could plug it in there. If I knew a point, I could plug it in there. I simplify, I get the equation of a line. This is classic. This point slope formula helps you get the equation of a line. They did give me a point. I can plug that in. They didn't really give me a slope, but they said it's perpendicular to this line. So I would like to know his slope. How do I find his slope? How do I find his slope?
Solve for y.
Good. Put him in y equals mx plus b form. Yeah. If you put him in y, then you can see his slope. I can't really see his slope right now. But if I solve for y, is what you're saying, put him in y equals mx plus b form. Wow, that means, let me blow this up for you. That's an x minus 2y minus 5 equals 0. If I want him in mx plus b form, I want to move the x over. I want to move the 5 over. That'll leave me negative 2y equals a negative x plus 5. You follow that? I moved those guys over. I left this here. Now I'm going to divide by negative 2. And y equals, and when that's a negative 1 over a negative 2, I'm going to call that 1/2 x minus 5/2. So what is his slope? His slope is 1/2. But, let's just pause there a second. Solving for y puts it in y equals mx plus b, then you can see the slope, right? Now that I have his slope, though, I'm trying to make my own line that's perpendicular to that one. And if it's perpendicular to that one, my slope won't be that slope. My slope will be the negative reciprocal of that. I guess I need to have that memorized. What'd you say? Negative 2. The reciprocal negated is negative 2. Good. So my slope is negative 2. So my slope and my point 9, negative 6, I'll plug it into this formula and I'll get the equation of the line. I'll just do that. I'll move right over here where I got a little room. Here we go. Y minus a negative 6 equals my slope, which you said is negative 2, and then x minus 9. Yeah, that's it. That's actually a y plus 6. Do a little fast math here. Distribute the negative 2. Subtract the 6. Subtract that 6. And negative 2x plus 12. Yeah, we did it. I'll type that in and see if it works. Y equals negative 2x plus 12. All right. All right. Let's go check this out. All right. All right, no big deal. Everything's all right. So, that was a cool question. Any questions? Yeah, these are all good. They're all good. I feel like I want to help you with the more difficult ones. I don't know. I mean, so I'm going to keep flipping around here. I'm going to go back to some of those I skipped. This one might be bothering you. I do know students. I kind of know you guys. I haven't talked about this really. There's this funny notation up here. For this given function, they want me to do this. This thing is called the difference quotient. It's used a lot. We introduce it again maybe in pre-calculus. Like I said, I hardly talked about it. I think I might help you with this one problem, and that might be about it. I don't think you'll even make the test, but I'll just help you anyway. It comes up again in calculus, big time. So this is an interesting idea. But I'm going to blow it up here for you. It's f of x plus h minus f of x all over h. So they want me to do that to this function. This function is 24 minus 15x. In order to do that, do you know what this says? What does this say? Do you know, well, I'll tell you what it says. It says, go to your function and plug in x plus h. I mean, that's what this says. Go to your function called f and please plug in an x plus h. So I'll try that. My function called f is right there. It's 24 minus 15x, but instead of x, I'm going to plug in x plus h. That's me plugging x plus h into my function. Minus the function itself. That's just the function itself with x plugged in. Okay, well that would be this, the function with x plugged in. When you're subtracting something, parentheses are important. It's 24 minus 15x. The function with x plus h plugged in it minus the plain old normal function. You with me? That's how you read that, and that's what you do. And then it's all divided by h. And it's a messy algebra problem. The truth is, though, when you distribute and clean things up, it turns out to be beautiful. It cleans up beautifully. It cleans up beautifully. But students tend to have a little hard time with just that beginning. What the hell is that saying? They don't understand how to read that and do that. So I just tried to help you. When you clean it up, watch what happens. I'm just going to move over here a little bit where I got some room. I'm going to go 24 minus, I guess I'm distributing the 15, 15x minus 15h. If I distribute the negative 15, here comes a negative sign. I'm going to distribute that. Negative 24 plus 15x all over h. And like I said, it cleans up beautifully. Things cancel usually. Watch this. The 24 cancels. Hey, that negative 15x cancels with the positive 15x. If you distribute things correctly, things will cancel. I'm left with a negative 15h over h. And now the h's can cancel. And the answer is negative 15. It's just an exercise. It's like getting up and doing 10 push-ups in the morning, or 2 push-ups in the morning. Negative 15.
Can you do the last one?
Good job. Yeah, the last one on this, in this 1.4. Okay, remember, I'm going to work my way up there here. There's something else I might want to do. So I just left this problem quickly. I'm sorry about that. Are you guys okay with what I just did? Again, the beginning part tends, I know, that bother students. And by the way, I just want to make another comment. You know, when you plug something in a function, you plug an x value into a function, you get a y value. And when you plug an x value into the function, you get a y value. I just want to point out that this is like the subtraction of 2 y's. Is what it is. And then, right, this is sort of disguised, but this is sort of the subtraction of 2 x's. So this is sort of a slope, this thing we just did. in a weird kind of way. It's a slope. The answer was the slope of that line, actually. The answer was the slope. Okay, sorry. You know, I don't know if I've talked about this all that clearly. Check this out. They want to know if this is a linear function. There's a bunch of data there. Is it a linear function? You know, to be a line, to be a linear function, it's got to have this constant slope, this consistent constant slope that goes up 7 and over 12, or up 7 and over 12, and it always goes up 7 and over 12, or whatever it is. If I just look at this data kind of closely, just check it out. How are these x's changing? How are these x's changing? From 10 to 20 to 30 to 40 to 50?
10.
I guess they're changing by 10. So, you know, if I'm thinking about my slope, you know, the change in y over the change in x, I just decided that those x's are changing by 10. The change in x is 10. What about the y's? Is there a consistent, or does it, anyway, looks like that one, and I could subtract my y's to figure this out, or I can see that it changed 20. What about the next one? 20. What about the next one? 20. What about the next one? 20. Okay, then it's a line. If there's a consistent change in y and a consistent change in x, then it's a line. And the change in y is 20 and the change in x is 10. That's a line with a slope of 2. Right. Right. I mean, if one of these was different, just one of these, then it wouldn't have a consistent slope. It has to have the same change in x and change in y. And when you set it up as a ratio, it needs to be the same. This one was a consistent slope of 2. I mean, I think yes. And I could tell them now they want the equation of the line. That's interesting. How do I get the equation of the line? I mean, I just found the slope is what I did. Now, if I have a slope and a point, I can get the equation of a line. Do I have a point? Dang right. I got a chart full of points. I got 5 of them to choose from. You're right. Right. So I could get the equation by doing my y minus, well, it doesn't matter. I'll pick that first point. Y minus 565 equals the slope 2 times x minus 10. I decided to use that point and that slope, and that's the equation of the line. I should clean it up. I should clean it up a little. Distribute the 2, add the 565, plus 545. Hey, you know what I was just thinking? Maybe I should have known it was 545. I mean, I did the math, because whatever, that's how I did it. But now that I know the answer, you know what? I could have went back here. If these are changing 10 every time, what if I went back 10? If I went back 10, I'd have an x value of 0, and if I go back 10, the y's should go back 20, so it would be 545, and I just stumbled onto my y-intercept is what I did. And then I would have known I have a slope and a y-intercept, and I could have sort of skipped this work. But you don't have to. Look, while we're on that topic, let me just see something. Watch this. Is this a line? Is this a linear set of data? Is it linear? Watch. And at first glance, you might not think so. You know, I need to see if it has a constant slope or a consistent slope. So, you know, that problem was nice. This one's not nice. I mean, how much does x change every time? Well, it doesn't change the same every time. It changed 2, then it changed 1, then it changed 3, right? So hang on, what's my y doing? It changes 6, then it changed 3, then it changed 9. I should just I mean, I'm doing this in my head. What I should do maybe is calculate the slope. What's 18 minus 12? Sorry, 18 minus 12 over 2 minus 0. You know, that's one way to calculate that slope. What is that? It's a 6 over 2? That's a 6 over 2, which is a 3. So what if I did it with another set of points? Let me just try the last set of points here. 30 minus 21 over 6 minus 3. That's 9 over 3. What's 9 over 3? 3. Yeah, I think the ratio, I mean, even though the changes look a little different, the ratio is always a ratio of 3. When this changed 2, this changed 6. That's 6 over 2, that's a ratio of 3, that's a slope of 3. When this changed 1, this changed 3. That's a ratio of 3, that's a slope of 3. When this changed 3, this changed 9, that's a ratio of 3. All right, it's got a slope of 3. It's a line. Could you write its equation? Y equals, what's its slope? 3x. Oh, and the reason I started to do that is because I think I see the y-intercept. Do you see the y-intercept? When x is 0, that's the y-intercept. So, 12. So I didn't bother with this equation because this equation's good when you have the slope in any old point. When you happen to know the y-intercept, use this equation, right? You got the slope and the y-intercept, you're done. Finished. Keep clicking through there. You did ask for the last one. I think there's some other good stuff here. Let me see. Yeah, and one of the things we'll do, I'm looking at some homework, but I'll hand you back those quizzes before we leave, and maybe we can talk about those quizzes too. Yeah. Let's try this guy. An electric board determines its monthly bills for residential customers by charging a base price of $14 plus an energy cost of 10.34 cents for each kilowatt hour used. Wow, that's kind of complicated sounding, but then they want me to write an equation. I'll be darned. Is it easy or what? Yes. I think it is easy, even though it's got a bunch of scary words in there. I think there's a starting value, sort of an initial value, and then a rate of change. I think there's a slope. A rate of change is a slope, and a y-intercept. They charge a base price of $14. So no matter what I use, energy-wise, my bill's going to be $14. That's my y-intercept. That's sort of how it starts. That's the starting value of my bill. Then it charges me $10 or 10.34 cents for every kilowatt hour. That's a rate of change. And I think I can write an equation. I mean, I think that's a slope and that's a y-intercept. I'm going to write y equals my slope times x plus my y-intercept. They are a little tricky here, though. They want this to be in dollars. Let's just keep track of this a second. They want this, it says y to be in dollars. What was this 14? Was it in dollars? It was in dollars, so that's cool. But what about that 10.34? I don't know. If that's 10 cents, then I shouldn't call it 10. then this looks like $10. I mean, they said they did use the word cents. If it's 10 cents, how many dollars is it?
You gotta move it up.
It's right. So that was a little tricky of them, but it's this many dollars. That's 10 cents. It's this many dollars plus $14 is your equation. Unless they screwed up that question. I think I'll just try it. All right. Good job. What did you say? Oh. Right. The answer was this one. Right. I had to get it in dollars. I had at 10 cents. I had to get it into dollars by moving the decimal. That's dollars. Yeah. Yeah. Okay. There's other good questions amongst here. I like these word problems. I feel like maybe that's where you might need some help. Look at this one. I like this one. Let's do this. This is another one where I think they want the equation, but this time I don't think they give me a starting value and a rate of change. I don't know. I read it real fast. Let me see. Let me reread it. A company finds it can produce 10 heaters for this much cost. So let me just 10 heaters, $3,100, and it produces 15 heaters for $4,450. And now they want to write the cost as a linear function, blah, blah, blah. They want me to come up with the equation. And this is not a slope and a y-intercept. This is not a rate of change and a starting value. It's, how would you describe this? I would describe this as 2 points. You're right. They gave me 2 points is what they gave me. You got to read these and see the difference, right? I tried to point that out the other day. That one type of word problem gives you a slope, like the last type of word problem gave me a slope and a y-intercept. This one gave me 2 points. X is 10, the cost is $3,100. When X is 15, the cost is $4,450. When I write it like this, it's clearer. But now I can, so what do I do when you have 2 points? You find the slope, you play that game. Can we play that game? I'll play that game. When you mark the set go, I'll probably beat you. I'm gonna race, I'll race you. 4,450 minus 3,100 over 15 minus 10. My slope is 1,350 over 5. Everybody knows that's 270. I mean, I said I beat you, but I didn't mean I had to wait up here forever. Thank you. You guys right? I'm right? Thank you, thank you, thank you. What do I do? Oh, now I got the slope and a point and a point. I do my point slope formula. Yep. Same old thing, same old thing. Y minus the 3,100 equals the slope 270 times X minus 10. Yeah, that's good. That'll work. Real quick, that's Y minus 3,100. That's 270X minus 2,700. I'll be adding a 3,100 over here, and there we go. There we go. Cool. I could type that in, but I just won't even bother. I'm pretty sure I'm right. Okay, so there's some more. There's probably another one like that. They probably gave me 2 points. Here's another one that's not a line, and they want an average velocity. That's interesting. I didn't really talk about this. Hey, when you think of the word velocity, what do you think of? Speed. Okay, that's okay. And can you put some units on that? Like, what would you think? Like the speed. What do you think of when you think of speed? What do you think of driving down the road? You think of miles per hour, right? So miles per hour, like a distance over time. In this one, it's not miles and hours. In this one, it's a ball going up in the air. It's in feet and it's in seconds. So I guess it wouldn't be miles per hour. It would be feet per second. But my little explanation, what I was trying to get to here was that when you think of velocity, you should think of a slope. You should think of a rate of change, is what I'm saying. A rate, a miles per hour. So it's a slope, and it's distance over time. Your y's, it's like your y's over your x's, except your y's are distance and your x is time. Velocity is classic slope. So, did they give me 2 points? They did. They said t is 1, and they said later on that t is 4.25. But they did not give me the y values. How do I get the y values? How do I get the y values? They want this. How do I get the y value so I can do a slope? Plug them into this function. Right, plug them into this function, get your y values, and then you can do the slope. And that would be an average velocity. That's cool. I'm not going to do it. I'm just leaving you hanging there. Okay, that's a good one though. You didn't mention the word slope, but velocity is slope. I never said that last few days, but it's good to say now, finally. Okay, you said the last one, right, sir? Yeah. Which is 21? I mean, the very last one, which is this thing. And it says to use the y-intercept slider. Did I try this one? This is one I might have. Anyway, I can't use the damn sliders. These sliders aren't working. Unless I don't know what I'm doing. So forget the slider. Maybe I can answer the question without the slider, okay, or without the interactive figure. But maybe I can't. It says set the y-intercept at 0, 4. Change the slope until the line passes through 1, 0. What is the slope of this? Okay, so I can't use the slider, but I could answer this question. That's kind of a cool question. Put the y-intercept at 0, 4. And then and then they wanted you to use the slider to move the line until it goes through the point 1, 0. So if it went through the point 1, 0, that would be here. And this is the point 0, 4. So they wanted me to do that. They wanted me to go through there and then change the line until it goes through this point. And now the question is, what's the slope of that line? And you know what? Just kind of look at the picture and tell, well, again, yeah, that's a nice question. Now that I drew the picture, what is the slope of that line? Down 4 and over 1, which is -4, right? Down 4 and over 1, you can just see it. Sometimes it's easy to see. Cool. Listen, but I'm having trouble with this interactive figure. Are you also? Yeah, okay. Listen, this shows up again throughout the homework, different chapters, and maybe it works better sometimes. I'm not sure what's going on with it at the moment. So sometimes there is benefits to messing with this interactive figure, but it doesn't seem to be working. It might be some, to use the interactive figure, it might need Flash, or it might need something to help it. Some little program to help it that it's lacking, or maybe it's just badly programmed. Okay, -4. Cool. All right, so maybe I'll bop out of 1.4 here a second. And what about 1.3? Any requests? Concerns? I'm going to jump toward the end again. Jump into the end of 1.3. Watch the I could watch the video. I don't think I need to watch the video. Let me try to answer this question. This is pretty easy, I think. This is the last question in 1.3. I got a mess up here. It says American women, the life expectancy of American women after 1960, T years after 1960, is this formula. Okay. Let's see what it says. Find the A-intercept. Well, that's weird. He never taught me about an A-intercept. Well, I guess they mean Y-intercept, I think, because they've got their function called A. That's like my Y. That's what they mean. They mean the Y-intercept. What is the Y-intercept?
73.
73. You can see it. Nothing to this. Nothing to this. Right. It's that. Right. What is the slope?
0.2.
0.2, huh? 0.2. And the rate of change? It is 0.2. Rate of change is the same thing as slope. They're going to make me put some words here. I wonder what the words are. Keep in mind, when the slope is 0.2 and the units are the y's over the x's. Hang on. What are the y's? What is the y value? The y value is this A of t, and it's the, what is it? The life expectancy of American women. What is x in this problem? X is t, which is the years after 1960. So 0.2 years of life expectancy every year since 1960. Geez, this is hard. This is kind of tricky, but, well, apparently American women, how about plug in a 0? What do you get when you plug in a 0? No, you get 73. I don't know if you can see this little, but when you plug in a 0, you get 73. That means in 1960, American women's life expectancy was 73 years. But I think every year that goes by, it must be going up a little. How much is it going up every year? 0.2. Anyway, that's what this is. It's the 0.2 years of life expectancy. It goes up 0.2 years of life expectancy every year. Does it say that? Probably that first one. Years of age per year after 1960. This is life expectancy per year. We could debate this. We probably need lawyers. I don't know. What do you guys think? You think it's the first one? Okay. All right. Thank you. Yeah, I messed with some of these the other day. This is good. They use some words. I mean, part of this class is knowing how to do some math, but we are learning some language, you know. We are learning some terminology. Real quick here, this is about a word problem about profits. And X is the number of units sold, and P is the profit. And look what they say. If you sell 400 units, you get this much profit. If you sell 475 units, you get this much profit. So it seems to me like they're giving me 2 points again. 2 points. And if you got 2 points, you can calculate the slope. But look what they asked for. They asked for the marginal profit. But then they tell me what that is. It's the rate of change of the profit. And we know what rate of change is. Slope. So this is a slope question with some different terminology, right? Find 2 points, find the slope. And then the units would be, I think, the profit over the X. Now what is X in this problem? Number of units sold. So it'd be per unit. It'd be the amount of profit, the dollars of profit per unit. Let me just see if I can read let me see if I can read that. Dollars per profit, I don't like that. Units bought per dollar, I don't like that. Dollars per unit sold.
Yeah.
I kind of like that, right? It's, units sold per dollar. No, that's upside down, right? It's, you got to have the Y's over the X's, or the profit over the X's, right? Cool. I want to try one more thing. I want to give you back your quizzes and let you look at that. Let me try one more thing here. How do you find your quizzes? Oh, they're there. Quizzes and tests. Did you guys just see what I did? I mean, when I go to all assignments, I don't see it. Do you see it? That's funny. In all assignments, I don't see your quiz, and up at the top it says homework and tests. No wonder I don't see your quizzes. But they should have all assignments there. That's kind of weird. But anyway, I can click quizzes and tests, and you do have something called a quiz. What happens if I got 60 minutes if I turn this on? Okay, it's warning me that. And here's your online quiz, and there's some stuff about domain and range. Well, actually, this is not domain and range, but is it a function or not? Every input should have one output. I'm not going to do it for you. I'm going to keep going. Is that a function or not? Go ahead and tell me.
Yes.
Yes?
Yep.
It passes the vertical line test. Yeah. Should get rid of my stuff. Hey, that's a good question about domain and range. There's a little picture of a function there. That's a good question for domain and range. The domain is the x values, and the x values go from, on the left, it looks like -3 to, looks like 5. -3 to 5 on the x. Probably that one. And probably including it. They got nice colored in dots. That means you include the -3 and the 5. So it's probably B. Let's look at the range. The lowest y value is 0. The highest y value is 5. So 0 to 5 on the range. Yeah, that's a good answer. That's easy. You can plug in a number. That's pretty cool. That's just the inputs and outputs, kind of. This first stuff is kind of inputs and outputs. And then we start dealing with lines. Let me see if I can find a real difficult one. They're all multiple choice. Yeah, what about this one? Look at this again. A boat is moving away from shore in such a way that at time t hours, its distance from shore in kilometers, I mean, these are just hard to read, is this function. So the distance is the y values, and the t is the time. And if you want to think about its slope, it says, what is the rate of change of the distance from shore? So the rate of change is the 3.5, the slope. So you just see it and read it, and you're done. Oops, let's get the units right. Is it 3.5 meters per second or kilometers per hour? I guess it's, yeah, it says hours and it says kilometers. Right, that's right. It's reading. This class has turned into reading all of a sudden. You get to do a little math. I like these sentence things. Interpret the slope. This is where I'm asking you to think about the slope as a rate of change and put some words on it, you know. In this problem, first of all, what is the slope? And again, it's tiny up here, but that's a 458 plus 50x. What's the slope? The 50. The 50, the number in front of x is the slope. 50x. So the slope is 50. The number in front of x is the slope. When it's in this form, y equals, see, it's y equals mx plus b, but it's actually b plus mx, right? Right. And what are the units? So it'd be 50, you know, what are the units? If I read the problem, it's the y values, I think, is the cost of tuition. cost of tuition, and the X values are, number of credit hours per credit hour. Are you guys following me? This is good practice. You think about these slopes, you think about Y over X, and you put some units on there, and it helps you realize what it means. So the tuition increases $50 for each additional credit hour. The tuition increases $50 for each additional credit hour. See, it is 50 over 1 is what it is when you think of 50. I think that's it, you guys. You guys shook your head at me, but I think that's it. The tuition increases $50, because it is a positive 50, every additional credit hour, per additional credit hour. I think that's what it is. I hate to do your quiz for you, but I like looking at these problems. There's another one that's good. That's good stuff. This is classic, easy stuff. You can do these. We've been practicing all these. Yeah, you can do these. So I'm submitting my quiz. So I got a bad score. It tells me what I got right and what I got wrong. I got them all wrong. It doesn't really let me go back and see. I don't know what I have some settings on this quiz. I think you can see which ones are right and wrong, maybe. So when you do it again, you can take some notes and improve your score, perhaps. You get 3 chances to do it before Tuesday. Okay, let's I'll just turn this off a second. And maybe I'll turn this off a second.